Here. Now the second is tetramolecular model of SO3. In the tetramolecular, 4 molecules of SO3 combined with each other. So it consists of 4 SO3 molecules. 1, 2, 3, 4. This consists of 3 monomeric unit. It consists of 4 monomeric unit. Clear? SO3 can exist in 2 forms. One is tri-molecular, other is tetra. Clear? SO3 can also form n number of monomeric units with the chain structures, but they are highly unstable. But SeO3, you see the structure of SeO3, it can form n number of monomeric units. Like SO3 can all form, but the addition, the structure of SeO3 can exist like this. So they are the polymeric unit of SeO3, and they are solid in nature. Solid in nature. So this is the structure of SeO3. This is also the simple addition reaction of SeO3. Simple addition reaction of SeO3. Upon hydrolysis, SO3 treated with H2O in presence of H plus, it will give H2SO4. It will give H2SO4. Similarly, if H2O is treated with acidic water, it will give H2SO3. Here, sulfurous and sulfuric acids. Now, H2SO4 is highly hygroscopic in nature. So it can absorb water to dilute. So SO3 is added in H2SO4 to stop the process of this. Suppose let's say we have taken H2SO4, use of SO3. SO3 is used to protect this H2SO4. There are two types of solution. One is primary standard, or is secondary standard. The solution absorb water from atmosphere and get diluted. For example, if you prepare H2SO4 100%, 100% pure H2SO4, clear? It absorbs H2O from atmosphere. It absorbs H2O from atmosphere, and the 100% is become 99, then 98. Slightly it is decreasing. Let's say in the lab you required 100% pure H2SO4. Prepare it 100% pure H2SO4, packed and sent to lab. On the way, it absorbs water. So if it absorbs water, it will reach 100% to the lab or decreases. Decreases. Sometimes decrease to 90% because it is highly hygroscopic in nature. Okay. So to prevent this, we add SO3 to H2SO4. This is called fuming of SO3. Fuming of SO3 in H2SO4. Now, I will prepare. I have prepared 100% H2SO4. This is 100% H2SO4, and in this H2SO4 we have added SO3 in term So bubbles of SO3. This is called fuming of SO3. Now this is a mixture of H2SO4 and SO3, which is known as oleum. Which is known as oleum. So this is the oleum mixture. Now, as we prepared 100% H2SO4 and added SO3 gas, if it absorb water now, this SO3 bubble will react with the water and will give H2SO4. इसका मतलब आपने 100% प्योर H2SO4 बनाया, उसमें SO3 फ्यूम की, अब वो रास्ते में जाएगा, वाटर एब्जॉर्ब करेगा, सल्फ्यूरिक एसिड बनेगा, तो रास्ते में भी सल्फ्यूरिक एसिड बता जाएगा, प्योर मिलेगा. तो लेकिन प्रॉब्लम ये है कि इफ यू बाय 100 ग्राम ऑफ H2SO4, 100 ग्राम H2SO4 एंड SO3 मिक्सचर ओलियम आपके पहुंचने तक उसका वेट बढ़ेगा या कम होगा? हाँ, तो इसीलिए घटेगा कैसे? बढ़ेगा. तो now the problem is that if 100 gram H2SO4 increase its weights due to adsorption of H2O, due to adsorption of H2O, तब इस ओलियम की परसेंटेज डिफाइंड होती है, ठीक, एंड परसेंटेज इज ऑलवेज ग्रेटर देन 100. लेट्स से this is a oleum mixture and the percentage is 110%, and percentage is 110%. What does it mean? It means if you buy 100 gram oleum mixture, you will get 110 gram H2SO4. Is it clear? If the percentage is 105, that means if you buy 100 gram oleum mixture, the weight of H2SO4 you will get is 105. So let's say this is oleum mixture and the percentage is 110 and the percentage is 110. You have to calculate the free SO3 present in this oleum. Question है, you have to calculate free SO3 present in this solution. All other center post your answer. Presence of free SO3 in oleum mixture having percentage 110. $21. Any other center? What is free SO3 present in oleum mixture which consists of 110%? The percentage is 110. See, there are two methods to calculate this question. One is H2SO4 plus SO3. The weight is 100 gram. If the percentage is 110, that means H2SO4 form is 110 gram. Okay. From 100 gram of H2SO4 plus SO3, you will produce 110 gram H2SO4. The first method is, let us assume that the weight of SO3 is X and the weight of H2SO4 left is 100 minus X. Okay. So this 100 minus X is not involved in the reaction with water. So the weight of H2SO4 100 minus X will be as it is in the H2SO4 from 110. Okay. Now this SO3 is now from H2SO4 and it added some amount of H2SO4 in 100 minus X value. So can we write this SO3 react with H2O to give H2SO4? If it is X gram, X by 80 is the mole. X by 80 multiplied by 98 is the weight of H2SO4 produced from X by 80 moles of SO3. Okay. Now the total mole of H2SO4, 100 minus X directly from H2SO4 plus 98X by 80 can be written as 110. From this you can able to find the value of X. Clear? So X will directly be the percentage because out of 100 you are getting this X. Clear? The second method is that you see the change in weight. Change in weight is 10 gram. We are able to add conservation of mass. If 10 gram weight increase, that means water added it will be 10 gram. Additional water will be absorbed by the solution 10 gram. Then moles of water is 10 by 18. This mole equals to this. So you can able to calculate X by 80 equals to 10 by 18. You will get the value of X. Both are same. Clear? Clear? So SO3 is used for making OEM mixture to protect the H2SO4 from water. Clear? So these are the oxides, sulfur, selenium, right? The type of oxide, there are different type of oxides we can able to classify a different mod also, based on the acidic nature, based on the basic nature, based on the type of oxides formed. Any metal, when reacted with oxygen, it forms metal oxide of type M2O, which again treated with O2 to give M2O2, which again treated with O2 to give MO2. I am assuming that our metal is monovalent. That means the oxidation state of metal in all elements is +1. Okay. So if it is +1, that is we can able to take that metal as metal oxide or alkali metal. So this M2O, see this M2O, the metal is in the +1 oxidation state and oxygen in the 2 minus. Okay. So this is called as metal oxide. In M2O2, metal is in the +1, whereas the oxygen is -1, -1. So this is a peroxide linkage. Clear? And there are two metal both attached with the -1-. In this structure, this is OO. This oxygen consists of one additional electron, therefore -1. This oxygen in the radical form. This is neutral. So entire O2 consists of 1-. Okay? And this is entire O2 consists of 2-. And here one oxygen consists of 2-. So I am increasing the oxygen content and decreasing the individual charge. Okay. If the size of metal are small, it exists in this form. That means if I'm talking about lithium, Li2O is the stable form, exists in oxided form. If the size is little bit higher, like sodium, form in the peroxide form. If size are much more higher, like KO2, CSO2. So which type of oxide form is depend upon the size of this metal. Higher the size of metal, higher with oxygen content. Here, now when you add water to this type of metal oxide, acidic water is added, it will give you hydroxide, which are basic in nature. When the hydroxide is treated with carbon dioxide, it will give you metal carbonate and 2 CO3. When peroxides are undergo acid hydrolysis, it will give you MOH plus. This will also give you peroxide, H2O2 and MOH. Clear? So H2O2 can be achieved by treating Na2O2, which is also known as oxone. Clear? So based on the oxides, you first write down. Clear? So based on the type of oxide which we form, these oxides are first classified as a normal oxide. It consists of M bond. They are very simple: H2O, MgO, Al2O3. The second is peroxide. In normal oxide, oxygen always consists of 2 minus, and in peroxide, oxygen consists of 1 minus. The most common peroxide is H2O2, hydrogen peroxide. Okay, hydrogen peroxide gives oxygen, free oxygen. H2O2 gives H2O and half O2. Clear? So to deal with the solution concentration, we use a term molarity, normality, mole fraction, formality, right? But in H2O2, especially for H2O2, in industry, they use a new term which is known as volume strength. They use volume strength. Why they are using volume strength? Actually, H2O2 is used, or H2O2 is a very good source of oxygen. Okay, so in industry, they want some reagent which produce oxygen. Clear? So now, if I will give you two solutions, both consist of hydrogen peroxide. This is also H2O2. This is also H2O2. The molarity of this H2O2 is, let's say, 5 molar. The molarity of this is 7 molar. Through molarity, you can able to get that 5 molar means 5 mole of H2O2 is present in 1 liter of solution. Now, you are going to take H2O2 because they are the source of oxygen. So from this 5 molarity, you have calculated that from 1000 ml, there are 5 mole of H2O2. 1 ml, 5 by 1000. This is the mole of H2O2. Then 1 mole will produce half mole. This much mole will produce this much oxygen. Then you can able to predict that, okay, this solution, if I 1 ml, will give this much of oxygen. Then you have to convert it at STP because there are mole. So this required large number of calculations. Then you can able to get that H2O2, this solution of H2O2 to give this much of oxygen. Volume strength is different thing. What volume strength says? If I say, I will write volume strength of this H2O2 is 5 and volume strength of this H2O2 is 10. Okay, let's say volume strength I explain now. Let's say I have written that volume strength of this solution is 5, volume strength of this solution is 10. Now what does it mean 5? That means if this solution you will take 1 ml, if this solution will take 1 ml, it will give 5 ml oxygen at STP. And the volume strength of this H2O2 is 10. That means if you take 1 ml of this solution, it will give 10 ml of oxygen at STP. So how you define volume strength? It is the 1 ml H2O2 gives X ml oxygen at STP, then volume strength is X. Then volume strength is X. So it is very easy to calculate the amount of oxygen produced by that particular H2O. Clear? Clear है? Now let's say this H2O2 is 5 molar or molarity की जगह अगर normality, let's say the normality of the H2O2 is N. Normality is N. Now I need a relation between volume strength and normality. Calculate the relation between volume strength and volume strength equal to how much normality you have to calculate. So if the volume strength, we have calculated the volume strength in terms of normality. Assuming that the normality of this solution is N, nothing is given. Now volume strength and normality, there is a relation between volume strength and normality. You have to find the relation between volume strength and, okay, what else, sir? Well,